Today's lesson is going to be on density. So if you'll pull out the density worksheet, and this is also linked to the website, your Canvas website, so you'll be able to pull this up and you'll be able to see the entire problems on these examples that we're working. First, let's define density. All right, density is how tightly packed particles are in a substance. How tightly packed particles are in a substance. All right, so the more tightly packed those particles are, the higher the density value. So let's look at some practice problems. And in order to do some practice problems, we need a formula. Density is defined as the mass of the substance divided by the volume of the substance. So if I want to calculate the density of a sample of gold, which has a mass of 110 and a volume of 5.7 centimeters cubed. So density is mass divided by volume. So my mass is 110 grams and my volume is 5.70 centimeters cubed. So when I plug 110 divided by 5.7 into my calculator, I'm going to get a density of 19.298, etc., etc. Now, we want to make sure we do our correct number of significant figures. 110 has 2 sig figs, 5.70 has 3. So my final answer here needs 2 sig figs, which is 19. What are my units? Grams divided by centimeters cubed. All right, let's look at number 2. Mercury has a density provided. If the graduated cylinder containing this mercury has exactly 55 grams, we want to find the volume. All right, so if density is mass divided by volume, my problem has provided the density. The density is 13.6 grams per milliliter. We are looking for volume. When we divide, we write V. We tell the reader what we are solving for. We're not going to just use a symbol X like we would in math. We're going to define what is X. X is the volume, so we're going to write V for volume. And my problem tells me that I have 55 grams. So I'm going to put 55 grams in for the mass. And when I solve for this problem, and I am going to get a volume of 4.044 and a whole bunch of other numbers. Now, this was technically 55.0 grams, so I should probably be better and put in the 0.0 there. All right, and so when I look at this here, I see that my final answer needs 3 sig figs, so 4.04, and my units are going to be milliliters. Find the mass of the methanol that fills a 125 container, and our density was provided for us. So density, again, mass divided by volume. Our density in the problem is provided for us, 0.79 grams per milliliter equals, we are now solving for mass. Again, we're going to write M. We're going to define what we're solving for. And our volume is 125. milliliters. So when I plug this into my calculator, I'm going to get an answer of 98.75, and I'm going to go ahead and round that up to 2 sig figs, so that is 99, and my units are going to be grams. All right, let's do one with water displacement. So this says, well, let's talk about what is water displacement first of all. When I am putting noodles in a pot of water at my house, if I fill the pot up with too much water and then I add the noodles, the water comes out of the pot. Has that ever happened to you? I know it's happened to me. The reason this happens is because when you put those noodles in the pot of water, the water level rises up. We call that it is displaced by the volume of the noodles. So when I put an object in water, the water level will increase by the volume of the object in which I put in. So when I want to do number 4, when an object with a density of 2.7 grams per centimeter cubed is placed in a graduated cylinder containing 52.4 milliliters of water, the water level rises to 74.9. So essentially, if I have my graduated cylinder, and here's my graduated cylinder, what I started with was a graduated cylinder with water in it, and it had a value that was red of 52.4 milliliters. Now, when I add in my object, the water level rose, so I now have more water. Not really more water, it just appears to be more water because it has rose, it has been displaced by the volume of the object. So the water level itself is now 74.9. So what is the volume of the object? To find that, we are going to take the final volume minus the initial volume. And I spelled initial wrong, but I spelled initial wrong. You should spell that correctly on your paper, initial. Okay. So the final volume is 74.9 minus the initial volume is 52.4. So 74.9 minus 52.4, that's going to give me a volume of 22.5 milliliters. So what that tells me here is the object had a volume of 22.5 mils. Now we can solve and find the mass. The density is 2.7 grams per centimeter cubed equals the mass that we are solving for over the volume of the object, which we have found using water displacement to be 22.5 milliliters. Now, you may look at this problem and say, uh-oh, we have an issue. We have centimeters cubed here and milliliters here. But if you remember from the activity we did in class, 1 milliliter is the same as 1 centimeter cubed. So these units are essentially interchangeable. We use the centimeter cubed for objects that have a regular shape, like a square. We use the milliliter if they are an irregular shaped object, okay? But these units are essentially able to cancel each other out. So when I solve here for this particular problem, I get 60.75, and my unit is going to be grams. And I'm going to put this into 2 sig figs, so that's going to be 61 grams.